I actually took a college course at Northwestern in Netlogo, so I guess that'll be the same models library I show you. Let's see. My name is Mike, so now you know. Here. So they have a whole set of models libraries, so you can go through, you find whatever you want. Let's go to social science. So this was the model that I showed in college, cooperation. So it's cooperation versus competition. And the way it works is you're going to set it up and you're going to have initial cow set up. Let's see if we can do full screen with this. All right. And I think there's a way to make some of this stuff bigger. So actually, when you write the code, you like build this stuff out. So this is the actual model. I'll explain a little bit about Netlogo actually, I guess. So you can just add stuff right here. And if you want to add a button, let's see. Button, slider, switch, chooser. So the way the buttons work is they make things happen. So it's kind of like you're calling a function from this GUI. So the two buttons you'll see here is there's setup and go. In the code, to setup and to go are right here. So these all have functions that are associated with them. So there's a to move, to eat, to reproduce, and that's in the to go. So over here you'll see to move, right? And if energy is less than 0, die. So to move, that's at the end, right? Otherwise, random, they move forward. They set the energy minus metabolism. So what they're doing in this model is they're eating and they're trying to reproduce. And if they can't reproduce, then like if they have too little energy, they die. And if they have enough energy, they can reproduce. So they have to eat the grass. And then the way the model is designed is to separate those cows who are cooperating from those cows who are competing. The ones that are cooperating, obviously, they let the grass grow a little longer. The ones that are competing try to eat up the grass before any other cow can eat it. And so, based on this, we'll find out whether cooperation or competition is more useful. So, as I said, the buttons kind of call functions. The sliders set a variable. So in that way, you can set these variables at the beginning of your model. So in the code, you'll see these variables. Let's take a look at one. Initial cows right here. And then code. Initial cows is in the setup. Setup cows. Create turtles. They call these the agents turtles in Netlogo. So initial cows is the number of cows you're going to create, the number of turtles. Then it's going to set it on an XY. Set XY is a built-in command. There's a whole, if you look at the documentation for Netlogo, there's a whole series of built-in commands like create turtles, set default shape, and this is really fun. I was trying to build a model for the company I work at, just as a toy, something we could use to determine the optimal compensation of people based on their expected outputs, and it's generally salespeople at our company. So based on how they're traveling and how they're making sales, you can figure out how to compensate them. So that would be one model. So using some of these things, you can just create a model. So this model, in particular, we're going to set a reproduction threshold. So how much energy does the cow need? So the way that you find out what the models do and you figure out what cooperation versus competition do is you change the sliders. You move them around, and then you run it. So let's run one of these. All right. So let's set, we'll keep cooperation probability high. We'll say reproduction cost is low. Reproduction threshold higher. And then let's just keep the grass at the level, metabolism where it's at, stride length. So what it does is you see the red cows are cooperating. The blue ones are greedy. So in this case, what you see is the greedy ones, they're killing each other at the beginning, right? And then after a while, what happens is they start to interact with the cooperative cows, which are, because they're working together better, they're reproducing more. And then after they interact with them, they're killing off the cooperative cows. So that's kind of what this model's telling us right now. So what, I guess, how much time have I spent? All right. Yeah, I don't want to spend too much time. But basically what I learned was from this model, after running it a whole bunch of time on different simulations, was that if the environment is prohibitive, so hold on one second, I got to think about this. So if the environment is prohibitive, cooperation benefits everyone. So if your environment is prohibitive, then you have to cooperate in order to survive. Now, if the environment's plentiful, then being greedy, it will get you ahead. Because what you'll do is you'll end up shutting down all those cooperative cows. So that's kind of the central point of this one thing. So we can try to see where we're going to make the cooperative cows survive, right? Let's try to make that happen. So in this case, let's say their metabolism is higher. Let's see what happens there. So now you see the greedy cows are losing energy before they can reproduce, right? They're being restrained by their own need for more energy. So what they're doing is they're eating all the grass, there's no grass left, and then they're dying off. So there's a reproduction threshold, they have to have 123 energy. So as they're trying to get to that energy level, they're eating too much grass. So they can only hold on for a little while. And so if we reduce it a little bit, we can try to look for kind of a happy medium equilibrium, right? Where can both sides survive? So kind of the ideal situation out of this is that, well, obviously big data is kind of taking over the world. And I know a lot of big data is machine learning now. And simulations allow you to create massive amounts of data. So as big data gets bigger, you're going to see a lot more simulations, I think. You're going to see a lot of machine learning models building these variables, these sliders, these situations, and then you're going to see the output of multiple simulations being used to find an equilibrium point in data. So I guess that's all I got for you. It was a surprise lightning talk. Maybe it was helpful, maybe not. If anybody has any questions that I might be able to answer, please let me know. It's written, I believe, mostly it's written in Scala. I know it started around like the late '90s, and Scala started around like 2001, right? So I think some of it, like it was written in Java originally, and then Scala as well. Um, that's something I haven't tried. No, I've done it a little bit. It like changes the outlook, so you can go 3D. Let's see what we can do. And then you like can rotate this stuff a little bit. So, right? And then I think you can run it here maybe, but I think it would be actually there we go. I mean it has a really good graphical user interface, and it's kind of like flashy in the way where if you were trying to show something to some executive and you were like, oh, like it's kind of kid-like, and you can mess around with it, and it's kind of a nice toy. So,
You're good, Mike.
all right, thank you.